Hi, I'm Simon, and today I want to run you through the Parajet Paramotor Test Cell. The main purpose of having a test cell is that you've got a really controlled environment. We can measure a whole bunch of characteristics, temperatures, output power, lambda, electrical output. So all the sensors from the test cell all come back to the data logging computers, where we can record things like the RPM, the thrust generated by the propeller, temperatures, fuel flow, and lambda, the exhaust gas sensor. It's all logged, so we can look back at those readings and have before and after if we're changing the tune. Obviously we've got CCTV, so we can monitor the test cell and see that everything's happening okay. And we've also got some sensors to look at, like noise, air pressure, airflow through the test cell. At the moment we're using the test cell mainly for our R&D projects, but over time what we hope to offer is the ability for customers to bring their machines in to see exactly how they're performing and leave in the knowledge that their machine is in top tune and developing the power and fuel economy they're expecting. So we mount the machine in the test cell using the hang points of the paramotor. Firstly, because we know that that's how paramotors are supposed to be suspended, but it also means that we can actually put any model, any size into the test rig. We've got a thrust line here we can make sure is exactly in line with the prop, with a load cell that very accurately measures the actual thrust of the machine in the thrust line of the propeller. For the throttle, we mount the throttle in a universal rig which we can coat with any throttle design, left or right, and we've got external actuators that control the throttle and the stop button that are controlled from the safety of the logging stations. That allows for two things. One, it safely means that we don't have to operate it and be inside the test cell when we're running, but it also means that we can automate sequences, and so we can run particular RPMs, accelerate, decelerate, and check temperatures, and do all the tests we need to do for some of our detailed R&D work. Once in the test cell, we fit a whole bunch of other sensors. So we obviously have an RPM pickup, cylinder head temperature sensor under the spark plug. We fit a sniffer tube up the exhaust tailpipe for getting lambda sensors. We've got the ability to plug in an external fuel source into the paramotor so that we can accurately, with a very high quality fuel flow meter, monitor fuel consumption during our tests. And the whole test cell is sound-proofed and sound insulated so that we can get some acoustic signature, we can get some noise readings from the paramotor in the test that we're doing. We also have a sound-deadened air intake so that when we close the doors we've got adequate airflow. And unlike many test cells that we've had previously, the machine is right in the centre of the airflow, so we're getting as clean an airflow as we can. Parajet have always invested in their test facilities, and this test cell is just a continuation on that process. But we're already investing in new equipment and new facilities to allow us to test technologies that are going to go into all our future designs. We've also now got a hyperbaric test cell on site, allowing us to test engine tech at very high altitude and at very low temperature, and so this journey continues.